The R is the software of R can be downloaded from CRAN. It has two major segments. One segment is called base R, and other thing is called external libraries, which is I represented here everything else. So external libraries are developed by some data scientists and some data analysts, the which supports some models. Suppose a linear model suppose is not available into the base R, then some data scientist has developed the linear model and prepare a library for a linear model. We have to include that linear model library in the core functionality additionally, and that linear model functionality will be included in base R. So some external libraries are available. You have to be familiar with the external library because that is very important. Most of the time we have to deal with the library, external libraries. So internal libraries and external library, we can use these two terms for these two concepts. Internal libraries are these packages. So libraries are packaged utilities, stats and data sets, graphics, graphic devices, grid, method, tool, parallel compiler, spline. These are the different packages which are available in base R. We have not to write down any additional function for including these libraries into R. Other packages are external libraries, about 4,000 packages on CRAN that have been developed by users and the programmers around the world. If you are, suppose R part is a library which is used for classification model and cluster analysis package. I have cluster package, and this cluster package will be used for mm, cluster analysis. So analysis by analysis, we have to choose which package is suitable and which package is needed by the user at the requirement. So at the requirement, you can use the library function to include that specific library. These are the functionalities in R. R is case sensitive. R is open source, means you can download free of cost, and code is also available for the both Windows and Mac, and this can be downloaded from CRAN website. The cran.r is a platform where the R is available, and you can download all of the libraries and all of the core part from this CRAN website. R manuals can also be downloaded. R can be installed using a USB. So there is no need you have a must be a system installation at your computer. So that can be installed on a USB, and that USB can be used on any of the system which does not contains the R. Now this is the R Studio. So what is the difference between the R and R Studio? R is the language and R Studio is a UI, user interface. So R Studio is a layer upon the language. The core functionality can be done with the help of R. But what the R Studio does, R Studio is basically providing us a user interface, which is very helpful for us for making the scripts, running the scripts, and uh, executing the code and maintaining the files. Graphs can also be shown by using the GUI. Otherwise, it is quite difficult for us to manage. Without RStudio, we can work in R, but in that case, you have to work on the notepad. So instead of working in the notepad and executing and compiling the files with the notepad or by some compilers of R, so it is very easy for us. The one thing you have to install is the R language, first step. And the second thing that you have to install is the R Studio. So R Studio is what? R Studio is a user interface. So it has the 4 windows by default. So you can see these windows here. This is called R script. any of the R code will be typed here. So it is nothing, it is just a notepad here associated with the R. Now, the second thing which is very important is the data objects. What objects are we have? Suppose I have some variables created here. So these variables will be shown here. If I created some matrix or some arrays, that arrays will also be shown here. The history environments can also be shown here. So all the data objects will be here. And all the file objects and the plots are here. What packages are included? So you can see in the data objects, there are the two tabs. One is the environment tab, other is the history tab and Git tab. We also have a Git tab here, which associate us with a Git library. Now the next is the console. Console is a command line. So your commands will be executed here. So you have to type a command in console and press enter. That command will be executed. If this command is creating a variable, that variable will be shown here in the data object. The last window here, we have file, plots, packages, installation, and the help panels. So this is the UI of R, and you are already familiar because you are in 7th semester. You can easily understand what these 4 windows are, and the collection of these 4 windows is known as RStudio. And whatever we did in RStudio is compiled and executed by the backend compiler, which I installed by using the R language. Now, few commands I am going to demonstrate here, like data cars. If you type a command data car here, then that can be what this command does. This command associate cars data object into my current session. So car object is installed and stored into your installation part of R. And when I use the command data cars, that object will be associated in my current work session. So car objects contains what? That can be that can be shown by str cars. Str, so cars is what? Cars is a data frame. In R, cars is a data frame. And what are the fields in this data frame? What are the data types of each field in this data frame? That can be seen by str. Str stands for the structure of car will be shown. Then head cars, how many rows I have in car, that can be shown by the head cars. The first 6 or the first 10 rows of the car object will be shown. And then we have a plot segment, variables in car, a graph will be shown by that variable. Now you can see the scripts which is already provided to you at your course website. If I want to execute the first line, just park the cursor at line number 1 and press the run button. The only line number 1 will be executed. If I want to execute the more than one line, select all of the 4 lines and then press run. Then all of these 4 lines will be executed simultaneously. Now run command data cars. So here you can see the output. Here you can see the variable list, and here the command will be executed. So in our console, the command is executed and the output of that will be shown here. Now the second one is str car. Str car will do what? You can see the structure. So what is the structure? Data frame. Data frame is the main component of data in our 50 observations of 2 variable, and you have numbers, speed, and the distance. So it contains the 2 variable. One variable is the speed. Num means the numeric variable, and what observations it has. Few observations are shown here. The second variable is distance, and this is also a numeric variable, and the few values are shown here. The third command is what? Head. Head 6 lines will be shown. So you can see the output of the head command. The row number 1 means the car number 1, and the speed of car number 1 is 4, distance is 2, speed of car number 2 is 4, and distance is 10, and so on. Now if I click on the plot command, so it will form a graph. So you can see the graph on my right side bottom window. What is the name of this graph? Can anyone of you tell me that? This graph is plotted, and the name of the graph is scatter plot. And this scatter plot have interpretation of scatter plot. One variable is speed, second variable is distance, and the points are aligned upward in direction. If the points are aligned upward in direction, means if the speed is increased, then obviously it will cover the larger distance. If the speed is small, then we have a very smaller distance to cover. So speed is directly related with the distance. It is related to the R. R stands for the correlation. So scatter plot indicates the correlation, and the range of correlation is from -1 to +1. So I am not calculating the correlation. I am just specifying the relationship. If the points are very close to each other, indicates we have a stronger positive correlation. If the points are away from each other, then we can say that it has a weak correlation. The strong correlation or the weak correlation is one of the important aspect of this plot. And in this graph, I am observing that the points are not too concentrated, so we have a not too strong relationship among these two, but it has positive relationship. So this is the conclusion. If the points are going downward, indicating that we have an inverse relationship, and if the points are very close to each other, indicates that the stronger relationship we have. If we have a points which are scattered away from a central line, we can say that is a very weak relationship. If these points are close to this line, suppose these are the points which are very scattered, but suppose I eliminate few of the points, like these points I have eliminated and these points I have eliminated. So the remaining points are very close to my line. So if that is the situation, we can say that we have a strong relationship. So speed can be used as a predictor for estimating the distance. Speed can be used as a good predictor of estimating the distance. So this speed will be a predictor and distance will be a predicting. Predictor means the independent variable, or we can call it as a controlled variable. The controlled variable means user has a control on speed, because if you push the accelerator with the force, then speed will be high. And if you push the accelerator by slight force or a weak force, then you have a smaller speed in of car you have. If the smaller speed of car we have, the distance will be covered by the car will be small. So that is the meaning of strong correlation and the weak correlation. If the points are very close to the line, we can say that it is a strongly relationship, and the model will be a good model. In that case, the model will be a good model. We have to predict the distance because it is a predicting. Predicting means what? Is a dependent variable. Predicting and predictor. So these are the important terms which you can use for this type of analysis. Predicting is the dependent variable, and this is independent variable. We can call it a controlled variable, and can be used the term controlled variable. Controlled variable means it will be controlled by speed. So I have no control over the distance directly. I have a control over the distance by using speed. So speed will gives us a control over the distance. I cannot change the distance myself directly. I can change the speed by pressing the accelerator of the car. By my force, it will be the distance which controlled. So as a stronger push I have of accelerator, the larger distance will be covered by the car and vice versa. X11 command will generate a new graphic window. If you run this command, then a new window will be shown in the output. And if I click on the hist command will do what? Hist command will generate a histogram of the data, and that histogram will not shown here on my plot window. It is shown on the new window created by X11 command. So now you can see the histogram. So now what the histogram is, what is the perception of histogram? Car dollar speed. So what is car? Car is a data frame which I initiated at line number 1 of this code, and speed is a variable. But this graph is not made by using the speed and distance. This is a univariate graph. This is not a bivariate graph. This is generated by a speed variable, and the next is frequency. So it is a one variable graph. It is not a bivariate graph. While scatter plot was a bivariate graph, this was not a bivariate graph. This is a univariate graph. So speed is a variable, and what this graph is indicating, generally we use this graph for assessing the normality of the data, whether the data is normal or not normal. So I can say that it is approximately normal, because normal means if we have exact bell shaped, we can use the term normal distribution. This is not normal. This is slightly left skewed, because you can see that the left tail is slightly longer than the right tail of the graph. So if your graph is exactly has this shape, we can say that it is exactly symmetrical or a normal curve. The normal curve is why we are interested to observe whether the data is normally distributed or not. This is very stronger important assumption about the procedures in data science, whether your data is normally distributed or not. If your data is normally distributed, then you can specify some predictive quantitative models for this data. If your data is not normal, then there is a restriction of normality in the some models. If the data is not normal, you cannot apply that specific model for data, right? In R, you can use the column name, and column name, a dollar sign, and a data frame name. This is called data frame, DF, or data frame name. So data frame name, dollar column name, this is the way of expressing the column in my code. And will be, this is the graph of the distances. This is a histogram of distances. This is somewhat different with the previous graph. Previous graph indicates that the data is normally distributed data, but you can see the data is right skewed data, because its right tail is longer than the left tail. So we have three distribution. One distribution is known as normal distribution. Graph will be like this. If you have a positive skewed distribution, your graph will be like this. If you have a negative skewed distribution, your graph will be like this. So it's depending on the situation that the distances are right skewed, while the speed is approximately normal or slightly. One question by a student that whether histogram can be made by using the two variable. So the answer is no. Histogram is made for one variable, one quantitative variable. Histogram can be made for one scaled variable. Scaled variable means is a quantitative variable. So this is one of the very important condition. Okay, if that variable is not, so distance is a scaled variable as well as speed is a scaled variable, but we cannot make a histogram by using the both of them. So if I am going to generate the histogram for both of them, so it will be shown into the two graphs. One is the histogram for distances and then histogram. If I am interested to generate a graph of two scaled variables, so that graph is scatter plot. Scatter plot will help us to show the outputs of two scaled variables. So for one scaled variable, histogram is preferable or a frequency curve is preferable. So histogram, this is histogram, while this is frequency curve. So when I show the graph, the curve on a histogram, I can use the term frequency curve. If I am showing the graph by using the rectangles or bars, so I can use the term histogram for that. Scatter plot is different. Scatter plot shows the relationships, while histogram shows the normality or skewness. Skewness is what? Skewness is the lack of symmetry. So it is symmetrical means no skewness. It has right skewness. It has left skewness. So skewness is another thing, and scatter plot is another thing. Now, first command you can see here is a GPA. So what the GPA is, GPA is a user-defined variable. So I am going to create a vector of some values. In R, if you want to create a new variable, so the way of writing is very simple. So you have to specify what you have to specify, the symbol, this symbol you have to specify. This is called assignment symbol. This is the assignment symbol, the less than sign with a hyphen. Here you have to write down the variable name, what the variable you want to define, and on the right side you have to specify the value. You can specify a single value. Suppose I can say that the x is equal to 5, then 5 will be stored in the variable x. If I have a vector, so it's quite simple. Or if I want to create an array, so that is simple. C for combined or collection. Either word you can use. C is a reserved word. So C is not my letter. C is a letter defined in R. The value one, comma, value 2, and so on. Value 2, and so on. So all values you have to use. That is the format of defining the array. The array or a vector can be constructed by using this. Then again, we have the same command, structure of GPA. So you can see the structure of GPA. GPA is not a data frame like cars. Cars is a data frame. In cars data frame, I have two variable. One is speed, other is distance. So it is just like as either speed or just like as other distance. So this is one variable. The name is not speed. The name is not distance. The name is GPA. And GPA 3 will do what? Third element will be shown. If I run this command will show you the value 3.22 in the output. So 3.22 will be shown if I run this command. If I run the command GPA 1:3, colon operator is an important operator. A colon operator will uh, gives a series 1:5. 1:5 means 1 up to 5. So all values will be used up to. So in subscript, I am defining 1:3. The GPA 1, GPA 2, GPA 3 will be shown. All the three GPAs will be shown in the output by this command. Then another variable or a vector is created. The name of the variable is first name and assignment operator, then C collection. First name is Jamal, Zafar, Saim, and Jia. So these are the names, and these names must be quoted because these are the strings, and a structure is shown. Structure will show you this is a string variable or a character variable. String is not name which is used in our character is the word which we use for this. So character variable has 4 names. Now what are the other commands in this output? Now the remaining commands are what? After creating the name, pass status. Pass status is true, false, true, false. So is a Boolean variable. So first name is a character variable, GPA is a numeric variable, and pass is a Boolean variable. And next is the gender is again a character variable, but it has some difference with the name. Can you explain the difference between the for name and the gender? The name is a string variable, while gender is a character variable, which is called in R as factor variable. It is a factor variable, a factor vector. Okay. Factor is what? Factor is it has 2 levels only. All values will be comprised on male and female only. So that is why we call it a 2-factor variable. 2 factors we have. Then structure of gender will be shown. The next is gender factor gender. What this command will does? This command convert a character variable into a factor variable, because this variable, which I was assuming that a factor variable is created, but it will not be a factor variable. This will be a character variable. So if I want to convert this into a factor variable, then structure gender can show you the structure gender will show you a character variable. So this command will does converting a character variable into a factor variable. And this is again a definition of the factor variable with 2 levels, and this can also be written as, so the same command can be written by 3 different formats. One is this, gender is defined, then gender is converted into the factor, then gender can be defined by the 2 levels, male and female, and that can also be shown as male and female labels as the, so this is the very strong command. What this does, this generate, this convert, not generate. Gender is created here. The gender will be converted into factor. It has 2 level, male and female labels. M is the short variable and male is the full name. F is a short name, female is a full name. So labels can be used for the long as a long name, and characters can be used for a, then structure gender will show you what will be the structure of this factor, this gender variable. The gender variable will shown by the factor. Ls will does your all variables in the memory will be shown by ls. So using the list object. And then this is an important command which is binding these 4 variables into one factor data frame. The data frame is created then. Now this is the time for, now I am going to execute these variables. Pala variable GPA, GPA is executed, GPA is created. So now you can see a GPA variable here in the variable list. Then second variable, first name is executed. A new variable first name is created here. You can see First name is what? Is character. 1 to 4 means 1, 2, 3, 4. These are the indexes. Ajmal, Zafar, Sayam, Jia. So these are the four elements which this. So these variables are now created, and pass variable, you can see a pass variable is created here. Logical, as I told you, it is logical because I wrote true false over there. True false will not be shown into the strings. Then I have to structure pass. Structure pass will do what? It will show you what is the type. So you can see it is a logical 1 to 4 true false. So this can also be seen here. Logical 1 to 4 true false. Structure command will does that. Now gender is created, and structure of gender, you can see the structure of gender. Structure of gender is same as character. Character 1 to 4. So there is no difference between the string and character. The string and character both are same. So what I have to do, I have to convert the gender into the factor. So this command will does gender is to be converted into the factor. I am going to run this command. This command, you can see here, factor variable is created. Now I can show you the structure of the gender variable. The structure of gender variable, it is shown here, factor with the two levels, male and female. One is indicating the male and two is indicating the female. So now list ls, what does ls will does you list of all variables in my memory is to be shown here. So just click on the car is the first variable, data frame, first name, gender, GPA, pass. Now I want to create a data frame which is named df1. So now df1 is created, and the structure, you can see the structure of this new. Now you can see the structure here. The structure can be data frame, 4 observations, 4 variables, first variable, and you can see that the data frame name, $sign, the variable name. First variable is a factor variable. Acha. Very important thing is what? Whenever we created the data frame, it by default convert a string into factor. So you can see the factor variable name is also a factor variable, gender is also a factor variable, but I am not interested to create the name as a factor variable. So I have to change the command. GPA is a numeric variable, pass is a logical variable. This is the structure. There is an error in this structure. What that error is, name is converted by default as a factor variable. So I have to change the name as a character variable. So now you can see how can we change the string variable and not forcing that into. This is the command. You can see not this is not the command. The command. This is the command for creating a factor variable, not enforces and not converted by default to the string will not be converted into factor by default. So string as factors, string as factor is equal to false. So it will create a, this is the same command as I did here, but with a one more parameter is there. And what that parameter is, string as factor is equal to false. So then when I run this command and show you the structure of the new variable, so you can see that now the name is same. Ajmal Azafar is a character variable. Gender is factor. GPA is numeric. Now is correct. Up to now, I have covered in this lecture two segments. One segment was this. In this segment, a built-in data frame is associated with my current R session, and I worked on that. In second segment, this is the second segment. I'm going to highlight this second segment. up to now, I have second segment. In this second segment, what I did, I create my own data frame. The one thing is what, how you can associate pre-installed data frame with the current R session, first segment. In second segment, if the data frame does not exist and you want to create your own data frame, the second segment demonstrate that. The third segment is now going to start. This third segment has to affiliate an external data file and a data frame is created. External data file name is usedcar.csv. The usedcar.csv is a data frame, but this is not by default available to the R session. So I am using an external command read.csv. What this command does, an external data used cars.csv is a file which contains my data, and all of you are familiar with the csv file. Read.csv will does what? Read.csv will read the data from this csv file and store in the df3 data frame. So what is df3? Df3 is a user defined word for the new area. And if you want to see what variables are included in that, so you can have strdf3, head df3, tail df3, means what? Means your data frame will be represented. Now I want to execute this command, but you can see an error. Why this error occurred? The reason of this error is the file used car is not available in my default folder. The object not found. The object used car cannot open this file because this file is not available into the current. So I already provided you this file into my course website. I'm showing that course website to you. So you can see course page of data science. Now you can see this course page, and at this course page you have this data file. So you can download this data file usedcar.csv. You can download the code I am demonstrating here in R from this website, and my presentation is also be available here. So there you have already provided lecture number 1, and the book is already is there. No, book is not there. I will upload the book by tomorrow. So let me give some time. Tomorrow I will upload the book here. Now I want to download this file, and this file has to placed into the default folder. So this file is now going to download, and then this file, the path, if I want to open an external csv file, that external csv file can be loaded by using read.csv. But when I executed this command, there is an error. The error was cannot open the connection, or file was not open. The reason of not opening the file, because I downloaded the file. The file is stored into the download folder, but by default, R will not look up that file into the download folder. It by default look up into the current directory of R. So we have to change the path. I change the path and C:\user del download. Then the file name is same. When I executed this command, you can see the df3 data frame is constructed, and I want to see the structure of this command. So if I want to see the structure of this command, so I have to execute that. So if I execute this structure command, I'm just pressing Up arrow. Up arrow will give us a concept. The last command, I can see the last command str of df3. So you can see the structure of df3. Df3 is a data frame. It is a data frame. It has 150 observations into the 6 variables. The first variable is air, second is model, price, mileage, color, transmission. So these are the 5 variables. These are the 6 variables. First variable, air is integer, 2011, 2012. Model of car, 3 types of models are available here. Is a factor variable, SE, SEL, SES. So these are the 3 levels. Price is integer, the price of car, the mileage is integer, the quantitative variable, color is a factor variable, black color, blue color, white color, transmission, factor variable, automatic, manual. I think all things are fine. And all of you are familiar with this data structure and this data frame. In this data frame, we have 2 types of transmission, automatic cars and the manual cars. Now I want to show you the other commands from this data structure or from this data frame. If I click on the left tab in the upper screen, so you can see that the code is there and df3 is there. I can close the data frame by just pressing the close button. Now the head df3 will give you the 6 rows, and tail df3 will give you the last 6 rows of this data frame. And if you don't want to convert the strings as factor, so still you can use the string as factor is equal to false with the read.csv. Now transmission is a factor variable. And now I want to demonstrate you how the subsets are generated in R. Very important data structure is a subset command. Subset, I want to create a new data structure. In this, I want to have only the yellow cars. So this can be done by executing this command. Yellow cars, subset, df4, color, in yellow. So this is in is what? In is a operator. The color will be searched to the yellow. Yellow is a constant, color is a variable or a column name, in is the operator. So this is just as a double equal to sign into your C. In C, you write down as a double equal to sign, color is equal to yellow is a condition. So color is in yellow is a way to write down into the R. So df4 is a structure, but df4 is, I first click on this and execute this command because df4 is not created up to now. Now the yellow car subset, I want to run this command, yellow car subset. If I run this command, a subset will be created. So that subset is, we can see this subset here. Yellow cars, not here. I'm going to, df4 is not created. The df4, first I have to create a df4. Df4. This is the command which create the df4, and df4 factor converted appropriately, then yellow cars. Now, acha, you can see the errors in all of these commands. df4 not found, df4 not found. The one thing I have to look over there, what was the error initially? This was the first command. Acha, that's the same error we are facing here because we have to change the path here as well. So the path, I am going to copy and paste the path from here and copy this path into this command. That is the error again I was facing. Now I want to execute this. df4 is created. There is no error. transmission is to be converted into the factor variable, and yellow car subset is to be created. Now you can see that the yellow car subset is created. Yellow car subset has all of the 6 variables with only 3 cars. So there are only 3 cars into the data frame which are of yellow color. So in this way, you can create any subset. And it is very important in data science how to create the subset of data. This is called segmentation. In a query language, you have to specify the queries, but in R, you have to use a subset command. Now another subset command, high mileage. High mileage is executed, and those cars who covered more than 100,000 mileage is a subset is created. If I click on high mileage, so you can see only these few cars has a mileage which is specified in the condition. The mileage is more than 100,000. So these are the cars in which the mileage is more than 100,000. Then another subset is created. That subset transmission is equal automatic cars. I want to have all automatic cars in a separate data frame. So another data frame is created, automatic cars. Now you can see these are the automatic cars. How many cars are automatic? You can see lots of car. I have automatic transmission. Now the next command is manual cars. So now this data set is to be split into the two. One is the manual car, other is automatic car. So half of the cars are kept into the automatic cars. The remaining cars will be stored into the manual cars. So these are the ways to create the segmentation of data. Now, how can we access the data frame? You can see these commands. These commands are quite simple commands. I'm not going to discuss these commands in detail. I am going to demonstrate the table command. It is very important command, table command. You can see the table command here. I am focusing on this table command. The table command, this is the table command. Table banana hai, table df4 with transmission. So this will give you a frequency table of the data frame transmission variable. Transmission is what? Automatic transmission or the manual transmission. So this will show you a frequency table in which I have how many cars are automatic and how many cars are manual. After executing this command, I can have the output of that. So just click run. So you can see at the bottom 120 cars are 28 cars are automatic and only 22 cars are the manual cars. So this is the way, which is a very simple way to create a data frame frequency table by any variable. Now in the next variable, pie chart, because we can construct the pie chart by using you can see the pie chart command, pie and the variable table, this frequency table and transmission. And I execute this command, a pie chart will be shown in the output on the right. On the right, you can see the pie chart here. Pie chart can be constructed for categorical variable. So transmission is a categorical variable or a factor variable. So this factor variable, we can create a pie chart for that. Automatic car, it means this is showing that only 20% approximately, I'm showing by my perception, it is 20% cars are manual, but most of the cars are automatic. In Pakistan, I think so it is reverses. Lots of car in Pakistan is manual, and the few of the new cars which are automatic. So automatic car has a smaller proportion in Pakistan as compared to the manual cars, but this is not the data from Pakistan. This is the data from somewhere else in the country where from this data belongs. The lots of car are automatic, but the few of them are manual. So that is the way of creating a pie chart by uh, any frequency table. So this is the box plot. In this box plot, you have to rotate the box plot to the clockwise, because smaller number will be on left side and the larger number will be on right side. These two numbers on the upper side and these two numbers on the lower sides are called outliers in data science. So in data cleaning, which is our next lecture, outliers. So outliers are those values which either are extremely small or are extremely high. So you have to remove these outliers before implementing the next part. So that is very important. This is called data cleaning. Removing outliers from the data is called data cleaning. So data cleaning is my next lecture, lecture number 2. This is not belongs to the data cleaning lecture. This is just data handling lecture. How can we handle the data in R by and create some commands by using the R. So now what is this? This is called Q3 third quartile. This is called Q1 the first quartile. And this distance is called IQR. What is IQR? Interquartile range. So IQR can be determined by Q3 minus Q1. So if you take the difference between the values of the third quartile and the first quartile, that distance will be calculated. This distance is called IQR. So IQR has a very significant features in data handling and data modeling, because IQR will gives us a perception. Achha, one thing which is very important, if we have, this is called right whisker. This is called right whisker. This is called left whisker. Because left whisker and right whisker both have approximately the same length. So I have a perception by looking at this graph as the data is symmetrical. So by this graph, if the left and right whiskers are both equal. One more thing which is very important, if this line, this is median. This is the median. This is median. If this median is in exactly center, I can use the term exactly normal distribution. So what is the purpose of creating the box plot? The box plot has a multiple purposes. The one purpose is to identify the shape of the graph, whether it is normal distribution or a right skewed or a left skewed. Another important element that box plot can identify are the outliers, whether your data has outliers or do not have outliers, and what is the interquartile range. These are the elements which we have into the perception of this box plot.